Hello everyone, welcome back. Let's continue with our chapter on force and motion. So hopefully from the previous lesson, you have now understood Newton's laws, Newton's first law and Newton's second law, and you should now be able to use F equals ma to solve problems. Right, so let's move on. Now, in the previous section, we only looked at examples where there was only one force acting on the object. But we know in real life that it's not always going to be the case. So we would frequently have multiple forces acting on an object. So imagine if you're pushing a box across a carpet, you're providing a force to accelerate it. But there's also a frictional force slowing it down. A light suspended from a ceiling is being pulled down by the force of gravity, but pulled by the tension in the wire. When several forces are acting on an object, their combined effect is to produce a certain acceleration. You can find a single force that would produce the same acceleration. This force is called the resultant force, or net force. Right, so in the red box here, give a little bit more explanation. So the resultant or net force is a single force that produces the same acceleration as several forces acting together. It is found by adding vectors representing the original forces. Okay. So let's look at one simple example. Here, there are two forces acting on particle P, as shown in the diagram. Let's find the direction and magnitude of the resultant force. So you can see here, we have two forces acting. We have 16 Newton acting towards the left-hand side, and we have 9 Newton acting towards the right-hand side. So imagine there are two people pulling the particle P. One person pulling with 16 Newton force, the other one is pulling with 9 Newton force. And then we would know that this person has a much stronger force here, which means the particle will actually move or accelerate towards the left-hand side. But what is the resultant force? Well, let's write it down. So if we assume the left-hand side is our positive direction, as we just talked about it using the example of two people pulling the particle, we kind of know that the object will move towards the left-hand side. Okay, so the resultant force would be 16 Newton, which is positive because we have assumed left-hand side is positive direction. But when I add the 9 Newton, now be careful here, I'm not just adding 9 Newton, I'm actually adding negative 9 Newton, and that is because 9 Newton is acting in the opposite direction to what we have assumed to be the positive direction. So really what we had is here, we'll have 16 minus 9, and that would give you 7 Newton. So this is the resultant force, and the direction is actually towards the left. So if we want to write that as the magnitude, we can write it down as magnitude of F equals to 7 Newton, and the direction is, I don't know what happened to my pen here, is to the left. Okay, right. Let's have a look at the second example where we have a few more things going on. So here it says there are three forces acting in a vertical plane with a unit vector I and J directed to the right and up, respectively. The force F equals to 5I minus 8J Newton. let's find the magnitude of the resultant force and the angle it makes with the horizontal direction. So just to clarify, what does it mean by the angle it makes with the horizontal direction? It means, imagine you have the positive side of the x-axis. So what you want is the angle it makes with the positive side of the x-axis. So it'll be from about here and then go somewhere. And we're going to find out the angle. But it's always from the positive side of the x-axis. Okay, well, let's start by finding the magnitude of the resultant force first. Right, so you can see everything's been written in vectors now. Okay, so let's start with our force. So we're going to use the I and J form. So our resultant force, here, F equals to, so we just need to add all those forces together and everything to be written in the vector form. Okay, so 8 Newton, now you can see it's towards the left hand side, and if I write 8 Newton in the vector form, and that would just be minus 8I. Okay, and it has no J component because it's not acting up or down. Okay, so that means 12 Newton, if I write it in I and J form, now it's not acting to the right or the left, it's only going up by 12 Newton. So that means that would just be 12J. Okay, so let's add them together. So let's add all those three forces together. So we have minus 8I plus 12J plus the final force here, which is given to us as 5I minus 8J. So when we add them all together, we'll find out that the resultant force F equals to, so minus 8I plus 5J, that will give you minus 3I. 12J take away 8J, that will give you plus 4J. Okay, so now our resultant force is given in vector form. However, the question asks us to work out the magnitude. So let's work out the magnitude for the resultant force, equals to the square root of minus 3 squared plus 4 squared. And the answer will come out to be 5 Newton. Okay, so this is the magnitude. Now we need to work out the direction it makes, or the angle it makes with the horizontal direction, which I have just explained before. It's actually with the positive side of the x-axis. Okay, so why don't we draw this vector out? So what does this force look like? What does the vector look like? So we have to go, imagine if we start, if this is our origin, okay. Now minus 3I means I have to go backwards by 3. And then 4J means I have to go up by 4. Okay, so this is our resultant force actually, which is minus 3I plus 4J. All right, so you can see here, this is a rectangle triangle, which means I could use trigonometry, SOHCAHTOA, to work out this angle here. Let's call it theta. Okay, so you can see that I have been given 4, which is the opposite, 3 is the adjacent, and this is the hypotenuse. So I don't know the hypotenuse, I know the opposite, I know the adjacent, which means I have to use 10. So that means 10 of the angle theta equals to opposite, which is 4, over adjacent, which is 3. So you can put in your calculator to work out that the angle theta, which is 10 minus 1 of 4 over 3, that doesn't look like 4, here we go, and theta come out to be 53.1 degree. But since we're looking for not this angle here, but actually the angle all the way goes from the positive side of the axis to this resultant force here. Oh, I wish I could have a different color. So really what we are looking for is this angle. I'll try to make it a bit more obvious. So this is the angle we're looking for. As you can see, I'm trying to color in here. Okay, so from the positive side of the x-axis, go all the way to the resultant force here. So you can see this is a horizontal line. So this is a straight line, which means to work out this angle we need, we just have to use 180 take away theta. Okay, so the angle we actually need would be 180 minus 53.1, and that would give us 126.9 degree. And this is the angle we need. Okay, so this is the end of example 2. Right, let's look at another one. Example 3. Okay, so in this case, here it says 2 children are pulling a box of mass 8 kilograms in opposite direction as shown in the diagram. Let's find the acceleration of the box. So we can see straight away that the force acting towards the right hand side is greater than the force acting towards the left hand side, which means there will be a resultant force and it should go towards the right hand side, and the box should be pulled towards the right hand side. Okay, so let's write down part A. Now, in this case, since we're looking for acceleration, so that would link with Newton's second law, which is F equals ma. So let's write that formula down first. Now, this F here, this force here, now would be the resultant force. Okay, so we have said we know that this object will start to move towards the right hand side. So let's say this is our positive direction. Okay, so what do we have? What are the forces acting on the object? So we have 26.4, and that's positive. And add, what else do we have? We have another force, which is 18.8, but since it's going in opposite direction, when we write it down, make sure you put a negative sign in front of it. So add a negative 18.8, and that will equals to ma. So what's the mass? That's 8 kilograms. So put 8 and then times by acceleration a. So now 26.4. So take away 18.8, and what would that be? So that would be 7. My pen stopped working. Oh, here we go. Oh, okay, I have some technical problem. The pen has now gone a bit crazy. Right, here we go. 7.6. Okay, so this is not a sign. Okay, don't mistake it as negative sign. So 7.6 equals to 8a. So that means a equals to 0.95 meter per second squared. Okay, So now we know the acceleration towards the right-hand side. This is 0.95. Then in part B, it says the acceleration of the box is now 0.7 to the right. Find the magnitude and the direction of force 3. So we have another force acting on it, and now being given the new acceleration. So part B, we need to think about our resultant force. So we still start with our F equals to ma, but instead of writing only 2 forces, we now have 3. So we have 26.4 plus minus 18.8, we have enough space, and plus the third force, which is F3, and that equals to m stay the same, which is 8 kilograms, times by acceleration. Now the new acceleration is 0.7. Okay, so that means we have 7.6 plus F3 equals to 8 times 0.7, that's 5.6. So that means our third force, F3, equals to 5.6 take away 7.6, and that would be minus 2 Newton. Okay, so that means the direction of this force is actually towards the left-hand side because it's a negative 2 Newton. So the direction is towards the left. And that's the end of this. Right, let's have a look at one more example and then you can try some questions yourself. Okay, example 4. A particle is subject to 3 forces as shown in the diagram. Given that the particle moves with constant speed, find F3 in vector form. Right, so now when something is moving at constant speed, that means there is no acceleration. Okay, so let's make a note, constant speed, which means acceleration is 0. So when we use our Newton's second law, F equals to ma, the F still stands for the resultant force. So we need to add all the 3 forces together using its vector form. So why don't we write that down first? So we have minus 3, 0, plus 5, 1, oops, 5, 1, plus F3, and that equals 2. Now m, we don't know m, but does it matter? It doesn't, because as we just said, the acceleration is 0, so it's m times by 0. Or since everything's actually written in column vector form, so really what I should have done is write acceleration is 0, 0 in vector form. Okay, so well, that's good news because now the right hand side will just be 0, 0. Okay, so we now have minus 3, 0 plus 5, 1 plus F3 equals to 0 and 0. So that means if we combine those 2 vectors together, we will have minus 3 plus 5, so that would be 2, and 0 plus 1, and that would be just 1. So I have 2, 1 plus F3 equals to 0 and 0. So can you see what F3 is now? So F3 will just equals to, we just have to take away this vector from 0, 0. So the 0 take away 2, so that'll be minus 2, and then 0 take away 1, so it'll be minus 1. Okay, so this is our force in vector form. Excellent. So this is the end of this section. Now, on the next page, I'm going to show you exercise 21B. And I would like you to try some questions from this exercise. And again, if you don't have the book, please pause the screen and have a look at those questions. The answer will be attached at the back as well. Please check your answer after you finish the question. So here's question 1. Question 2. Question 3. And question 4. Question 5. Question 6. Question 6D. Question 7 and 8. And question 9. And here's the answer for question exercise 21B. Question 1, 2, and 3. Here's the answer for question 4, 5, and 6. And then 7, 8, and 9. Okay, oops, sorry. Okay, so this is the end for this section.